Now we'll solve some mathematical problem uh, about gravitation and gravity and gravitation. Our first problem is, it says that if the earth is considered as a sphere of a radius 6400 kilometers. So here the given radius is 6400 kilometer. At what height the acceleration value due to the gravity will be 1 by 64 of the acceleration due to gravity on the earth's surface. Okay, so here first of all let the height be h. So let the height be h, and we know at earth surface, so at the earth's surface the acceleration due to gravity g is actually equals to, we know the equation is gm by r square. Okay, this is our equation 1, and we said the at the height h, so at the height at h our gravitation g prime will be equals to gm by r plus h whole square. Okay, this is our equation 2. So if I divide this equation 2 with 1, then I will get g prime by g is actually equals to r by r square by r plus h whole square. Okay, this is we know. Here a condition is given. So this condition is our acceleration due to gravity will be 1 by 64 of the acceleration due to gravity on the earth's surface. So at what height? So we say that at height h our gravitation will be g prime, and at earth's surface our gravitation will be g. So from this condition we can say that g prime is actually equals to 1 by 64 into g. So I substitute this g prime in 1 by 64 g, then I will get 1 by 64 g by g is actually equals to r by r plus h whole square. Okay, then if I cut down this g, then I will get r by r plus h is actually equals to root over 1 by 64, which is equals to 1 by 8. Okay, 1 by 8. Then we can say that 8r equals to r plus h. Okay, so from that we can say that h equals to 8r minus r or equals to 7r, and we know the value of r is 6400 kilometers. So it will be 7 into 6400 kilometers. Then our actual value will be this 7 into 6400 kilometers, which is actually equals to, so which will be equals to 44,800 kilometers. So at the height of 44,800 kilometers, our acceleration value due to gravity will be 1 by 64 times of the acceleration due to gravity on the earth's surface. So this is our height. So this is our answer. Okay, I hope you understand this first math problem. Then coming to the second one, it says that if the distance between the sun and the earth, if the distance between the sun and the earth be half of its present value, so we know earth is moving in an elliptical path where sun is one of the focus of this earth. So this is our earth and this is the sun. Okay, and this distance is known as distance between sun and earth. Suppose this distance is r. So our so given concept is this distance is now become half. Okay, so this distance now become half. So if this distance become half, then we have to calculate the number of days in a year. We have to calculate the number of days in a year. So we know for present situation, for this present situation, our time period T is 365 days. 365 days. So we can say that the sun and the earth, the earth moving around the sun in 3365 days. This is our time period T. And from that, if I say that our new distance is r1, then we can say that our new distance r1 is actually r by 2. So let our new time period will be t1. Let our new time period will be t1. We know a we know a formula, or we know equation of Kepler's third law. Kepler's third law. From that we know the time period is actually the time period square is actually proportional to the half of cubic axis of so the Kepler's third law is the square of time period is proportional to the cube of its mean distance. Okay, so from this equation we can say that t by t square by t1 square is equals to t square by t1 square is actually equals to r cube by r1 cube. So we have to find out this t1. So we can say this t1 square is actually equals to r1 cube by r cube into t square. Okay, so if I calculate this r1 by r cube value, then I will get t1 square is actually equals to, we know the value of r1 is r by 2, so you can say the r by 8, r cube by 8 into 1 by r cube into t square. Okay, so if I cut down this thing, then I will get t1 square equals to t square by 8, or I can write this t1 actually equals to t by 2 root 2. So we know the value of t is actually 365 days. So if I calculate this whole value, then I will get it is actually approximately 129 days. It is actually, if I take the approximate value, it will be actually 129 days. So if the distance between the sun and the earth be half of its present value, then the number of years will be 129 days in a year. Okay, so I hope you understand this problem also. In our next video, we will also solve more problems about gravity and gravitation. So I hope you understand the solution of this math problem. Please like this video and do subscribe to our channel. Thank you.